everyone, this is Keith from Developing Mathematical Thinking, and in our video today we're going to talk about the order of operations, which for most of you hits about 5th grade, depending on your situation and your state standards. So let's take a look, since of course from DMTI we want kids to look at order of operations iconically and conceptually, where most of us probably learned them very symbolically and with some acronyms and some little sayings to help remember them, which is fine. As kids are working on those symbolically, but of course we want to look at those conceptually with some iconic models, and so we'll do a few examples of those today. Before we begin though, there's 3 key ideas to keep in mind as you work with kids on order of operations. So number 1 goes back to how we talk about, especially those of you that have worked with us for a while, how we talk about multiplication, as really the iterator multiplied by the unit gives us the total, which bridges back into early grades when kids are learning that multiplication of the groups times the members equals the total. But once we get into fractions and decimals, sometimes groups and members don't make the most sense. So with starting order of operations, I would stick with whole numbers for a while, but it still is going to go back to really thinking about iterator times unit. Also, you get to think about those different division problem types that we have in some other videos, because when division is in our order of operations problem, depending on how we do the model will depend on which of those division types you're thinking about. Number 2 is to really pick a context that makes sense. So I tend to like rows of chairs, so many chairs in each row. It could be plants in a garden, or as you will notice in the DMTI materials, we really start the order of operation iconic models connecting to area. So you can also use area as a great context for these types of problems. Third key on order of operations problems is to really keep flexibility in mind. We have the commutative property, so sometimes this iterator multiplied by the unit is going to flip-flop back and forth a little bit. There's no set way to think about rows and columns when we think about 3 times 4. That doesn't mean that it's 3 rows, 4 columns, or vice versa. We need to be a little flexible there. And as I mentioned up here before briefly, we need to be a little flexible on those division problem types. So let's take a look at an example that's actually from one of the DMTI 5th grade worksheets and look at it in a model format. So let's say we have the expression 5 plus 3 times 2 minus 1. And we want kids to look at that from an order of operations view. It goes back to that iterator times a unit. So we really want kids to look at the expression and think to themselves, where in our expression is there an iterator times a unit? And so we want them to look that, oh, we have a 3 multiplied by 2 in here. So that 2 is really our unit that's going to be iterated 3 times. And that's really what's important in the models, because that's kind of what's important first, is that the unit's being iterated. So with my rows of chairs example, we might have 2 chairs in a row that becomes our unit, and kids can label that with the 2 up there. And then we want to multiply that or iterate that 3 times. So as you have maybe seen in some of our other videos, we can take that unit of 2, sweep it down, iterate it down a total of 3 times. So we end up with 3 rows of 2 chairs. Now we can start looking at the other numbers in our expression. If we want to handle this 5 plus first, that's at the beginning of our expression, and it doesn't really matter, this is back to flexibility. We could put a row of 5 chairs down here in our model. We could add a column of 5 chairs over here in our model. It doesn't really matter. I'm going to put them on the bottom. So I'm going to go ahead and put a row of 5 chairs on the bottom. For some reason, we have some parents coming into the classroom and we need to set up some chairs and some different formations for them. And then we have the minus 1 left. So maybe we decided, oh, one of the parents didn't show up. So now we can cross off one of those chairs that we placed at the bottom to give us an iconic model of this expression, 5 plus 3 times 2 minus 1. Now, as we're thinking about this, let's just adjust this a little bit. Let's go up to our expression. Let's pretend there's some parentheses around the 5 plus 3. So I think it's a great activity with kids then to use the same numbers, add in some parentheses, change the order of the numbers a little bit. Now let's look at how the model changes. So now we no longer have a unit of 2. Really, our unit comes down to what is in the parentheses. And we're going to talk about this at the end, but when we start putting variables in here, if you remember back thinking of reading this as the quantity 5 plus 3 times 2 minus 1. As we were learning to read this as the quantity 5 plus 3, that's really telling us that's the unit of 5 plus 3. So we have a different story now that goes with this expression. So we're going to have a different model that goes with this expression. So now, sticking with the rows of chairs, maybe we're going to have a row of 5 chairs. And then we need an aisle or something in our row. Who knows? Because then we're going to add 3 more chairs onto that row. So we have our original 5 plus our 3 chairs in the model. Now, remember, this is back when I said to be flexible. A lot of times we think of multiplication as the iterator times the unit. In this case, it makes more sense to think of this quantity or this unit in parentheses as our unit. Now it's being iterated 2 times. So we're going to take that row of chairs, iterate it a second time. So there's our unit of 5 chairs plus 3 chairs, iterated a second time, but my expression says to still take 1 off. So now I need to pick one of those chairs and cross it off to start down the path of solving that expression or evaluating that expression to eventually figure out the grand total. So one other way to look at expressions there in order of operations. So as I mentioned a few minutes ago, let's move forward into middle school a little bit, when we were maybe going to start thinking of this quantity as x plus 3 times 2. Of course, then by middle school, a lot of times we'll move this multiplied by 2 out in the front and then have this minus 1 at the end. And this is back when we were learning to read this as 2 multiplied by the quantity, or we like to use the structural component word of unit, 2 multiplied by the unit of x plus 3 minus 1. So that would be an extension for order of operations that, of course, moves into middle school. One more quick example with division. Since in our country, we've decided to have an order of operations where we work left to right. Not all countries have that, by the way. There's actually some differences in that worldwide, but we go left to right. So if we have something like 12 divided by 3 times 2 as our expression to evaluate or to model, to think about the order of operations, goes back to those 3 bullet points at the beginning. Let's think of some context that matters. So if we're going to stick with rows of chairs, now we have 12 chairs in our row. I'm not going to make the individual chairs this time, just like I could have done this before with the different units. We have 12 chairs in our row. Again, we talked about being flexible with division. This is a time that thinking of partitive division probably comes in a little handier to think of taking our 12 chairs, dividing them into 3 groups. So now we can partition our unit of 12 chairs into 3 equal groups, but now it's only one of those groups of 4 that we're saying we're going to iterate 2 times. So now we can take that unit of 4, iterate it 2 times. So there's our entire answer now in our model to go along with the expression 12 divided by 3 plus times 2 to end up with the 8 that we would get following our order of operations. Okay, hope that was a little bit helpful, thinking of order of operations with the iconic models and with some context to go along with it to maybe help your kids with that are struggling with the symbolic models for order of operations. Thank you so much for watching.